In this video we are going to discuss about the shifters. So on the completion of this topic, students will be able to find out the bit slicing and booth recording. In shifters, this shifters produces an n bit output based on the n bit data input, and also it contains a control input. So where the n input bits are placed as a shifted copies of the input bits, and it can be shifted from some number of bits to the left or right as it determined by the control inputs. The major thing is it contains the n bit output based on the data input, that is output is based on the input, and also it has a control input which can be shifted from left or it can be shifted to the right based on the control inputs. So here in this binary shifter, the control signals enable several function, that is 2 bits, to determine how many bit position to be shifted, that is 0, 1, 2 or 3, or it has to be full completely shifted, or it can be rotated. So rotated means R value is equal to 1, which determines whether the shifted out bits are discarded or it can be recaptured in the different signal. Either it can be shifted in the 1, or it can be shifted to the left, or it can be shifted to the right position. So the bit slice of this binary shifter are shifted either to the left or to the right. Some bits can be fall off, or some bits can be discarded. Now new bits which are shifted in the opposite sides determines whether it is having 1 or 0 in the shifted side or vacated shifts, and vacated bits should be rotated from the major thing, that is from towards the left or towards the end. So that we are mainly discussed in this shifter. And next one is barrel shifter. So barrel shifter is simple thing. Here we have the data wire and the control wire. So this shift a data word by a specified number of bits. In a combination logic, if you see that this can shift a data word in a specified number of bits, so that this inherently provides the binary operation to implement the unwanted operations such as logical shift to the left or to the right. In some cases this is limited to the fixed amount, and the one way to implement this barrel shifter is the sequence of multipliers, where this output of one multiplier is connected to the input of the next multiplier. So here we can see the example, that is we are taking the 4-bit parallel shifter with the inputs A, B, C and D. So this shifter can cycle the order of the bits from that is, if you are giving A0, A1, A2, A3, it can be changed from A1, A2, A3, A0, or A3, A2, A1, A0, A3. So it can be changed based on the left or right. And the major thing here is this is the fastest shifter while comparing with the other shifters, and this determines the shift of 4 and 2 bits. And the next one is logarithmic shifters. So this shifters is based on mux 3:1 mux cells, that is consist of 4 stages with the order of 1 bit, 2 bit, 4 bit and 8 bit. It also perform the following operations, that is shift right logical, shift right arithmetic, shift extension, shift left logical and shift left arithmetic. Here also we can transmit the different parts of the operation, that is to the left or it can be done to the right. Here this logarithmic shifter is mainly contains n input and n outputs and m selected lines, that is we call it as control lines. So this multiple and variable bit shifting are more desirable than the single bit operations. So several irreversible shifters can be proposed in the same sequence that is given in this diagram. You can see the out 0, out 1, out 2, out 3. Several bits has been here contain n bit and n outputs, which is more desirable to operate this operations in a single bit operation. So with this 2k of 1 plus 1 plus 2 into k minus 1, which we call it as bm of 2k plus 2k minus 1. And the next one is barrel shifter. So the same thing, this barrel shifter contains every data are passed from one transmission gate, only one transmission gates, and the thing is input capacitance is O of n, transistor is O of n square, and it requires the additional decoder for control signals. The same thing it is for the logarithmic shifter. It consists of transistors and long interstage wires, especially for cyclic shifters. And next is the cyclic shifter. So here we can see the finite field arithmetic. So here in normal cases the squaring is done in the cyclic shifting, and in the case of encryption DCT proposing unit, this operation is in the form of Reginald algorithm and the address generator. So the main thing is this can be used in all the applications, that is it produces the good multiplication and the inversion algorithm to realize the VLSI chips into developing new multiplication algorithm. And it computes the inverse elements as a regular, simple, expansible, and also it contains a bidirectional shifting. It can be implemented as a cyclic shifter with additional masking logic both in the right as well as left. Quiz questions on the shifters. Give the difference between the booth recording and the modified booth recording. Thank you.